Welcome back to our EOC review. Today we're going to be talking about exponential functions. So we're going to start by looking at the attributes of exponentials. So we've got y equals a times b to the x. This is our basic exponential function where a represents the initial value. And that initial value is not, like it cannot equal zero. Cannot equal zero. And then b is our common ratio. Okay. It says exponential graphs of horizontal asymptotes, or an imaginary line representing the value that f of x approaches. Remember that f of x is another way of saying y. So it's saying y is getting closer and closer to this, but it's not going to touch that value. For the graph at the right, let's identify these. So our initial value is going to be our y-intercept. So that initial value, that starting point is 5. B is our common ratio. So to find the common ratio, we need two consecutive points. So meaning that when it's when x is 0 and then when x is 1, those are consecutive. So I like to make my table and say x is 0, y was 5, and when x is 1, y is 10. And so you take the y value when x was 1 and divide it by the y value when x was 0. So 10 divided by 5. And that's going to give you 2. So that is our common ratio. The equation then, we're just plugging it into the a times b to the x. So we'd have y equals, and then a value is 5, and then we're going to say times 2 to the x. That was an ugly 2. There you go. And then our asymptotes, that's the line that y is approaching but never touching. That's right there at 0. So our asymptote is going to be y equals 0. Remember, a horizontal line is y equals, a vertical line is going to be x equals. And we're going to talk about growth and decay. So this one says as x increases, f of x also increases. And if you look at this graph, it's going up from left to right. So this is going to be exponential growth. If a is greater than 0, then b is greater than 1. And y equals a times b to the x, which means that it's opening up, we're not reflecting, and then our b will be greater than 1, and it's going to go up from left to right. So this one has to be exponential decay. As x increases, f of x or y decreases. And so again, this is talking about if a is bigger than 1, greater than 0. So if it's not negative, so it's a positive and it's opening up the normal way. If it's reflecting, this could be a little bit different. Then b is less than 1. Remember, it's going to be that fraction form, and y equals a times b to the x, or decimal. And that's going to go down. It's going to decrease from left to right. So when we're talking about writing growth and decay equations, you're going to use these formulas. So it's y equals a times 1 plus the rate to the x power. A is still your initial value or your y-intercept. And r is your rate as a decimal. Remember that you have to divide by 100 if they give you a percent. And x is going to be your time. Then exponential decay is y equals a times 1 minus the rate, because we're going down, okay, to the x power, where a is still our initial value, our y-intercept, r is still our rate as a decimal, so again, we're still dividing by 100 if they give us a percent, and x is time. So the example here says you open a savings account with a deposit of $500. The account earns 5.25% annual compound interest. Write a function to represent the balance after X years. So here's the thing that I need to identify. I I need to identify my A. My A is 500 because that's what I started with. That was my initial deposit. My rate is 5.25%, but I need to write it as a decimal. So I'm going to come over to my calculator and I'm going to say 5.25 divided by 100. And that gives me, oops, I have it set on float. I'm sorry, I had it set to round to a different. We're going to do this again. So it's going to give me 0.0525. 0.0525. So 0.0525. Okay. And now we're going to plug it into that formula. Now, if it's earning, we have to decide which formula. If it's earning, that's going to be growth. Okay. So I'm going to say 500 is my A times 1 plus 0.0525 to the x power. When I put that all together, that's y equals 500 times 1 plus that is just going to be 1.0525 to the x power. I don't know why there was a decimal there. Shouldn't have been. And then we're not going to talk about geometric sequences right now.